Hi and welcome to the second class on time and work. I hope you have watched the time and work class 1 video and you have practiced some similar questions. If you have not, I will suggest you to go back to that video, watch that class, solve all the questions that we did and do some more questions and then come back here because we are going to take off from where we left in the previous class. Okay, we had discussed basically the concept of work done per day, and how do you calculate number of days required when more than one person work together, some people leave, some people join and all that. We did that using three concepts. One was the concept of reciprocal, which we use in most of the questions. Second, we use the concept of percentage, and third, we use the concept of LCM. Okay, so let's move and look at some more questions of similar concept, slightly advanced, and then we'll look at man days and man hours concept, which will be the core concept that we will cover in this class. Okay, fine. So let's see this question. Very interesting question. Akash, Sunil and Rakesh, they take 20, 30 and 60 days respectively to complete a piece of work. How many days will it take to complete the entire work if Akash is assisted by Sunil and Rakesh every third day? That means day 1, day 2 and day 3. Here Akash works, here's Akash works, and here Akash plus Sunil plus Rakesh, all of them work. Okay, because Akash is assisted by Sunil and Rakesh every third day. This is the case. Now, any such case where you do not see same number of people working every day. So here you can see day 1 is different, day 2 is different, day 3 is different. What we do is we try to aggregate and add the work done for the number of days after which the cycle starts repeating. For example, here, if I add the number of work done in all these 3 days, then day 4 will be same as day 1, day 5 will be same as day 2, and day 6 will be same as day 3. So work done in first 3 days will be same as work done in next 3 days, next 3 days, next 3 days, and so on. So I can take multiple. So I should find out the total work done in 3 days, because then it is cyclical, then it is periodic, then there is a continuity and the same pattern will move on. Okay, so day 1 is 1 by 20. Day 2 is again Akash, so it is again 1 by 20, and day 3 is 1 by 20 plus 1 by 30 plus 1 by 60. So this much work will get done in 3 days. Okay, what is the LCM of this? 60. So I have 3 plus 3 plus 3 plus 2 plus 1, which gives me 12 by 60 or 1 by 5. Okay, so in 3 days, work done is 1 by 5. Okay, so now my work total should be 1 unit. So I multiply this by 5. So I should multiply this also by 5. So you see, in 15 days, work done will be 1. Right? So answer for this obviously is 15 days. 15 days is here, 15 days is here. Simple. I hope you got it. One thing that we have to be careful is in 3 days, what we wrote here, in 3 days, work done is 1 by 5. You should not say, this we were doing earlier, here in this question, you should not say that in 1 day, work done is 1 by 15. This will be wrong here because work is not distributed equally across the 3 days. Okay. On day 1, if you see work done is 1 by 20, on day 2, work done is 1 by 20, and on day 3, work done is 1 by 20 plus 1 by 30 plus 1 by 60, which is basically 63 plus 2 plus 1, 6 by 60. Work done is 1 by 10. So actually work gets done in the ratio of 1:1:2. Double work happens on day 3 because all 3 of them are working together. So work is not distributed equally. So this would be a wrong approach. So we don't do this. Okay, this is the first thing that you have to be careful, because work is not distributed symmetrically across my 3 days. So you should not combine them. You should not convert 3-day work to 1-day work. This will be wrong. Okay, so this is the first thing that you have to be careful here. Don't do this. Okay, instead we do this. In 3 days, work done is 1 by 5. What should I multiply 1 by 5 with to make it 1? So obviously I should multiply it with 5. So in 3 days, if 1 by 5 happens, if I'm multiplying the right hand side by 5, I should multiply my left hand side also by 5, and the equation will become, in 15 days, 1 work will happen. So the answer is 15 days. Okay, that is for the first question. There is a second question also. And second question I have purposely added because there is a very important concept there. Okay, so let's look at the second part. Now what happens? Akash works on day 1. So day 1, day 2, day 3. So Akash works on day 1. That means 1 by 20. Akash and Sunil work on day 2. So 1 by 20 plus 1 by 30. And all of them work on day 3. So 1 by 20 plus 1 by 30 plus 1 by 60. Okay, and then the pattern continues. So again, if I add for 3 days, I will get a pattern and then I can multiply. So let's add all this. So I get 60, 3 plus 3 plus 2 plus 3 plus 2 plus 1. This gives me 3, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 by 60 or 7 by 30. So in 3 days, work done is 7 by 30. Okay. Now, why I have taken this? Because if you remember in the previous question, in 3 days, work done was 1 by 5. 1 by 5, it was very easy to multiply it with 5. That is what we did. Okay, because it was an integer. But here, the problem is 37 by 30. So 7 by 30, you will have to multiply it by 30 by 7. Okay, so 30 by 7. Okay, so that will give you number of days. Now this right hand side will become 1 and the left hand side will be 90 by 7. Right? 90 by 7 will be 12, 6 by 7. Okay, but this is a wrong approach. This approach is wrong. Again, why? Because you cannot multiply it with a fraction. You can only multiply it with an integer. The reason for that is same amount of work is not happening every day. The amount of work that happens every day is different. Day 1 is different. Day 1 is 1 by 20. Day 2 is 20, 30. So it is 5 by 60 or 1 by 12. Okay, 1 by 20 plus 1 by 30 will give you 1 by 12. And day 3 is, so you again have 3, this is 1 by 10. So work happening on day 1 is 1 by 20, day 2 is 1 by 12, and day 3 is 1 by 10. All these days different work is happening. Okay, so we'll need to correct here. What we'll need to do is, and let's see this very carefully. Remember, in such cases, you can only multiply by an integer. You can't multiply by a fraction. So I can't multiply by an integer and get 1. So what I'll do is I'll multiply it with the highest possible integer to take it closest to 1. So I'll multiply with 4. Okay, here also I'll multiply with 4. Okay. Now when I do this, on the left hand side, you can see that you have 12 days. Okay, so in 12 days, work done is equal to 28 by 30. Okay, and 12 days is these 3 days, 3 days, 3 days, 3 days. So 13th day will be same as day 1. Now how much work is left? Work done is 28 by 30. Work left is 2 by 30, right? 1 minus 28 by 30 is 2 by 30. 2 by 30 is the work that is left. Okay, now one day, day 13. Day 13, A is going to work and he is going to do by 1 by 20. Is 1 by 20 enough? Work left was 2 by 30. A does 1 by 20. If I subtract this, you will see that you will get 60, you will get 4 minus 3. You still have 1 by 60 left. Okay, so now 13th day, A has worked, he has done 1 by 20. After that, still work left is 1 by 60. Okay, so then we move to one more day. We move to do day 14. Okay, day 14 is this work that can be done on day 14 is 1 by 12, but work that is required is only 1 by 60. Right, is only 1 by 60. So you can see that full day is not required. Okay, and now if you remember how much day is required, going back to our original formula, days required is equal to work to be done. Okay, total work to be done is 1 by 60, and work done in a day, okay, is 1 by 12. Okay, so that is 12 by 60 or 1 by 5. You need only 1/5 of the day. Okay, so 12 days, one more day, 13 day, and then 1/5 of the day. So the answer will be 13 1 by 5 days. Okay, this is not 1 by 2, there's a mistake. Let's make it 13 1 by 5 days. So answer will be second. We already knew that for the first question, the answer was 15 days. This 12 6 by 7, I told you how we got this, but this was wrong. You can't solve it that way. So answer will be 13 1 by 5 days. And hence, this is how this will get solved. So you'll have to go day by day, see how much work is left. So in days, let's write it this way: work completed and work left. Okay, so in 12 days, work completed was 28 by 30, work left was 2 by 30. After 13 days, 1 by 20 more got added. So work that got completed was 28 by 30 plus 1 by 20. The LCM is 60. So you have 56 plus 3, 59 by 60. Work completed was 59 by 60. Work left was 1 by 60. So we move to day 14. Day 14, work that can get completed is 1 by 12, but so much is not required. So you don't need whole of day 14. You only need 1/5 of the day. And that 1/5, if you have confusion, use the formula that we had discussed in the last class. Days required is equal to work to be done is the numerator and work done per day is your denominator. So work to be done is 1 by 60, which is the work left after day 13, and work done on day 14 is 1 by 12. So that will give you 12 by 60, which will give you 1 by 5. So 1/5 of 14th day would be required. So answer will be 13 1 by 5. Okay. Very important question to understand how the two things work. Okay, fine. Let's move on to the next question. Okay. So again, a very similar question to what we had done earlier, but this has a slightly different data. That's why I have taken this up. A, B, C can do a piece of work in 10, 12, and 15 days respectively. They started work together, but A left 5 days before the work was completed, and B left 2 days after A left. So if you remember earlier, we had said that A left after 3 days, B left after 5 days, whatever. That is fine because that I was giving you from the starting date. So A left 3 days after start, B left 5 days after start, no problem. Here the data is A left 5 days before the work was completed. Now I don't know when the work was completed, and he left 5 days before that. So that is what is different in this question. Okay. So what I will do is, I'll assume that the work got completed in X days. Okay, let's say the work got completed in X days. Okay, so A left 5 days before the work was completed. That means A in a day does 1 by 10, and he has worked for X minus 5 days. Okay, better to look at all of them separately. B left 2 days after A left. That means B left 3 days before the work was completed. You know, A left 5 days before, B left 2 days after. That means B left 3 days before the work was completed, and B does 1 by 12 in a day. So 1 by 12 into x minus 3. Okay, and C never left, right? C went on to complete the work. So C is 1 by 15 into x. This should be equal to 1. So this will be your equation. A has worked for x minus 5 days, B has worked for x minus 3 days, and C has worked for x days. Okay, let's open this. So x by 10 plus x by 12 plus x by 15 is equal to 1 plus 5 by 10 plus 3 by 12. Okay, 10, 12, 15, the LCM is again 60. So it is 6 plus 5 plus 4 is equal to 10 and 12. The LCM here also is 60. So you'll have 60 plus, in fact, 5 by 10 and 3 by 12 we could have simplified, but fine. So in fact 6 times 6 into 5, 30, and this will be 5. So 5 into 3, 15. Okay, 60 gets cancelled, and of course there's x here. So 6 plus, so 15x is equal to 60, 70, 80, 90, 105. That means x is equal to 7. So work got completed in 7 days. Okay, so the main difference in this question compared to the previous one was that people have left from the end. 5 days from the end, 3 days from the end. But that again you can solve very, very easily by assuming that the work got completed in x days. Okay, so that is the concept which I wanted to show you here. Okay, so now if you see, A has worked for, A left 5 days before the work got completed. That means A worked for 2 days. B left 3 days before the work got completed. That means B left after 4 days. And C worked till the end. That means C worked for 7 days. Okay, A, when he worked for 2 days, he does 1 by 10. So that means A has done 2 by 10 of the work. B is 1 by 12. So 4 by 12. That means he has done 1 by 3 of the work. And C does 1 by 15. That means C has done 7 by 15 of the work. And these three values, if you add, you'll get how much? Of course, you'll get 1 because they have completed the work. Okay, so this was just a recap of what we had done in the previous class with slightly more advanced questions. Now let's move to the core concept for today, which is we want to look at the concept of man days. Before that, what we have covered so far, work done is equal to time taken into rate of work. Rate of work is per day work, per hour work, or whatever. Okay, rate of work is equal to 1 upon time taken. Time taken is equal to 1 upon rate of work. All this we have done earlier. Okay, so if a piece of work is done in x days, then work done in 1 day is 1 by x. All this we have done and we have solved enough number of questions. Let's move on to this concept. X is to y is the ratio of number of men which are required to complete a piece of work. Then the ratio of the time taken by them to complete the work will be y is to x. Okay. What this means, let's focus on the next one. If x number of people can do W1 work in D1 days, working T1 hours per day, the number of people can do W2 work D2 days, T2 hours per day, then this is the relation. Okay, what this means now, this might look a bit complicated, but basically what it means is that we are going to define work in terms of man days now. Okay, we are going to define in terms of man days. What we mean by man days is, let's say 10 men can complete a piece of work in 20 days. Okay, now here we are taking 10 men, so there is one inbuilt assumption that each man works with the same efficiency. All the men are equally efficient. There is no differentiation between one man and the other. So I have 10 men, each person works with the same efficiency. That's one assumption that you'll take. So if 10 men take 20 days to finish a work, then I multiply both and I say that my work is equal to 200 man days. My work is equal to 200 man days. This becomes a definition of my work. Okay, so my work is 200 man days, and this is product of men into days. So for example, if you give me only one man, he's going to take 200 days to finish the work, because here again 1 into 200 is 200. If you give me 100 men, they are going to need 2 days, because 100 into 2 is 200. If you give me 50 men, they are going to need 4 days. 15 to 4 is also 200. So basically, my men into days becomes a constant. Okay, so MD is a constant, is K constant, or M1 D1 is equal to M2 D2, as long as the work is same. Okay, so M1 D1 is equal to M2 D2. Then if I further advance it, I say men days, and they work for certain number of hours in a day. Let's say 10 men, they work for 20 days and they work for 8 hours per day. I'm using one more variable. They work for 8 hours per day. So then if you see 10 into 20 is 200, 200 into 8 is 1600. So now it is 1600 man hours. And now my work will get defined as man hours, not man days. And I will say, no, this 1600 man hours is a constant, because that is the work. Okay, so my work is 1600 man hours. So men into days into time, which is 8 hours. This is a constant. Or M1 D1 T1 is equal to M2 D2 T2. Okay, which is exactly what you have here. M1 D1 T1 is equal to M2 D2 T2. Okay, so this. Then I introduce one more thing, that I say, what if I'm changing the amount of work? Okay, so let's say this first team is doing 1 unit of work, and the second team has to do 2 units of work. Then how do I compare them? They are not comparable. So what I say is, okay, let me divide it by work so that all teams do 1 unit of work, so that it is constant. So I divide M1 D1 T1 by W1, which is the units of work, so that it is per unit of work, and M2 D2 T2 by W2, so that it is per unit of work. So now, and my people, the efficiency is same. So now my, basically what I'm saying is that my man hours per unit of work is a constant. This is a constant, and this will not change. Okay, so my man hours, men into days into time, divided by work. Okay, so my man hours per unit of work is a constant, and this is not going to change. A very useful concept, and we use this in a lot of questions. Okay, let's understand this by doing some questions. So same thing here. So in fact, we will jump to the question. We saw the concept, right? So the concept, we saw man days and man hours. Okay, so M1 D1 T1 upon work. This is a constant. Okay, sometimes you won't have time, so only M1 D1. Okay, work will be same, so no need to divide it by W1 also. So M1 D1, I can say M1 D1 T1, or I can say M1 D1 T1 upon W1. Depends on how many variables are there in the question. So this is man hours. This is first one is man days. This is man hours. And this is man hours per unit work. So depending on the question, we can apply any of them, and they all are going to be a constant. Okay, so for example, let's look at this question. So we have the same data here. W1 is equal to N1 R over D1. So same thing. Okay, so let's look at this question. 21 content authors working 9. So 21 is the number of men. They work for 9 hours a day for 8 days. So days is 8. 9 hours a day. And this is the work. Work is 180 questions. So I'll divide it by 180 so that I can find out my man hours for every question, per question. So this basically gives me the man hours required to do one question. And one question, then it becomes standard. It is per unit of work, right? So we are applying M1 into D1 into T1 upon W1. And you know that this is to be equated to M2 into D2 into T2 upon W2. So I have how many less or more days are required by 14 content authors. So M2 is 14. Okay. Days I don't know. Days I have to find out. So I'll keep as D2 into time. They're working for 10 hours a day. So 10 hours. And they have to do 150 questions. So this is going to be your equation. And you can see that this has only one variable D2. Okay, so let's solve this. This is 2. This is 3. This is 4. This is 5. This is 30. This is 6. Okay. This is 2. This is 2. Okay. This 2 also gets cancelled. So dt is equal to 9. They need to work for 9 days. Okay. But the question, how many less or more days are required? So earlier they were working for 8 days. Now they have to work for 9 days. So the answer will be 1 day more. They'll need to work for 1 day more. That will become, so after solving, don't make the mistake of not reading the question and giving a wrong answer. 9 days is not the answer, because the question was how many less or more days are required. Less or more days compared to earlier. So earlier it was 8 days. Now it is 9 days. So you need 1 day more or plus 1 day. And that will become the answer for this particular question. Okay. So this is a classic example of M1 D1 T1 upon W1 is equal to M2 D2 T2 upon W2. All the 4 values were given here. Sometimes I told you time may not be given. Sometimes work may not be given, which means work is equal. And when work is equal, you don't have to take W1, W2 because both will be W1 and that will invariably get cancelled. So it depends on the question how much data is given. For example, in the next question, you will see. Now this looks like a very different question. The captain of an army has enough food to feed 28 soldiers for 15 days, equally divided over breakfast, lunch, and dinner. If 14 more soldiers join the camp after 5 days, how long will the food last? Now, this looks like a very different question. There's no work here. Okay, but the work can be compared to food. Okay, so food has to be eaten. So in fact, that is the work. And all these soldiers do the work of eating food. So my food will be work here. Okay, now, if you see, there are soldiers, so men, I have days. There is no time here and there is no work here also. So I'll assume that my work is same. So basically then I just have to do M1 D1 is equal to M2 D2. There is no need for T. There is no need for W. Okay, so just this much. Okay, so first let's find out the food is for how many days. There's enough food for 28 soldiers for 15 days. So 28 into 15, that means food is enough for 420 man days. Okay, that means if one soldier eats, he can eat for 420 days. If 2 soldiers eat, they can eat for 210 days. Okay, if 28 soldiers eat, they can eat for 15 days. That means the stock of food is equal to 420 man days. Okay. If 14 more soldiers join the camp after 5 days. So let's focus on the first 5 days. First 5 days, I had 28 soldiers. How much food will they eat? 28 into 5. This much food has already been eaten. 28 soldiers ate for 5 days. 28 into 5 is 140. So 140 man days of food is gone from 420. So 420 minus 140, I am now left with 280 man days of food only. Okay, fine till here. Now this 280 man days, now how many men are there? 14 more soldiers have joined. Earlier we had 28. 28 plus 14 is 42 soldiers now. Okay, into how many days the food will last? This is what the question is asking. Okay, so if you see, now 280 divided by 42 is how much? My days are equal to 280 divided by 42, which is 21 140. 21 140, can it be simplified further? Yeah, both are multiples of 7. So 3 and 20. So it is 6 2 by 3 days. So the food will last for 6 2 by 3 days. Okay, so what is 2 by 3 here? So 6 days is fine, but 6 days plus some more. Now if you see, food is equally divided over breakfast, lunch and dinner. That means 1/3 gets eaten here, 1/3 gets eaten here, and 1/3 gets eaten here. So I have 6 full days plus 2/3. 2/3 means 1/3 for breakfast and 1/3 for lunch. Both these together will be 2/3. That means I can have, after day 6, on day 7, I can have my breakfast, I can have my lunch, but I won't have any food for dinner. So food will last till lunch of, it should not be day 6, it should be day 7. Okay, lunch of day 7. Okay, because 6 days are complete. And then on day 7, I can have my breakfast and I can have my lunch. In fact, all these choices were day 7. Okay, so answer would be lunch of day 7. Food will last till lunch of day 7. Okay, so this looks like a very different question, but this again is the same man hours concept. Okay, and man hours, you can see that we could not apply M1 D1 directly. Okay, but if you want to solve it through the M1 D1 approach, I'll tell you how we'll do that. It will have to differ it slightly. So my initial M1 D1 is equal to M2 D2 plus M3 D3. Okay, which means, because this is the first 5 days and this is the remaining days. Okay, because days have been broken into 2 parts. So my M1 D1 is 28 into 15. This is my original quantity, is 28 into 5 days plus 42 into D days. So this is what I'll do. Okay, so this basically gets broken into 2 parts, and this is same what we solved earlier. It will give you 280 is equal to 42D, same equation that we had got here. Okay, so that way, if you see, same concept but a slight modified version of applying that concept here. Okay, so this is how your M1 D1 gets applied. In the previous question, M1 D1 T1 W1 everything got applied. Okay, so I hope we are clear with the concept of man hours. Okay, then man hours has one more very interesting application, which is this question. Now we told, so far we had assumed that everyone working has the same efficiency. The efficiency will introduce the concept in the next class, but what I mean that everyone does the same amount of work. All men work equally. Okay, now we introduce the concept of different people doing different amount of work. So if you see here, 2 men can do the same work as 3 women or 4 children. Though child labor is not allowed, but just for this question's sake, we will take it. So 2 men in terms of work done is equal to 3 women which is equal to 4 children. Okay, this is what. Okay, and see this very carefully. This is a very important question. Now I have 4 men plus 6 women plus 10 children. They work for 20 days to finish a work. Now this work I'll have to define in terms of man days. Okay, I can define in terms of man days or woman days or child days. Anything is fine, though let's go with man days. Fine, but conceptually you understood. So now this 4 men are equal to 4 men. 6 women. Now 3 women are equal to 2 men. So obviously 6 women will be equal to 4 men. Now this is a ratio, right? 2:3. Men and women is in the ratio of the work. Men and women, basically 2 men is equal to 3 women. So 2:3. So when women are 6, obviously this has to be 4. So 6 women can be taken as 4 men, right? And 10 children. Now if you see men and children, the relation is 2:4. Okay, or 1:2. Okay, so if children is 10, men will be 5. So 10 children is same as 5 men. So this is 5 men. So now I have total 4 plus 4, 8, 8 plus 5, 13 men working for 20 days. So my work is equal to 13 into 20, that is 260 man days. Same concept that we had earlier. My work is equal to 260 man days. Okay, and then the question says, then in how many days can 2 men, 6 women, 8 children finish half of the same work? So now they have to finish half of the same work. Okay, so basically I will use M1 D1 upon W1 is equal to M2 D2 upon W2, and W2 is equal to half of W1, right? So let's apply this. Work I have got, or simply you can see that my total work is 260 man days. In the second case, they have to do half of the work. That means they have to do only 130 man days of work. Okay, because work has become half. So you can put it this way also, which is also fine. And in fact, this is the concept method. I will prefer that rather than going the formula method. Okay, now again, what is the team? I have 2 men plus 6 women plus 8 children. I'll have to convert this again. So 2 men is 2 men, 6 women is 3 men, and 8 children is 4 men, right? So 2 plus 3 is 5, 5 plus 4 is 9, 9 men I have. Okay, into D number of days, they have to do 130 man days. This is what I'll get. Any doubt so far? Okay, so 9 men. So my D, number of days required, is going to be 130 upon 9. Right? 130 upon 9 is going to be how much? 14. So that is 90 plus 36, 126, 4 by 9 days. Okay, so days required are 14, 4 by 9 days. The answers are something else, I'm sorry, some error there. But days required are 14, 4 by 9. This becomes my answer. Okay, so just understand the steps. There are 3 steps here. First step was you convert your team to one manpower, man or woman or children. So I converted everything to men and my team changed. I had 4 men, 6 women, 10 children. That changed to 13 men. Okay, so that is the first part. Second part, 13 men work for 20 days. So my work is 260 man days. So I get my total work in terms of man days. And then third part is, now what is the team? The team is 2 men, 6 women and 8 children. and then again I convert them to 2 men plus 3 men plus 4 men. Okay, and this changed to 9 men. 9 men work for D days to do half of the previous work, that is 130. So days required is 130 by 9, and that gives me the answer. If I apply this concept also, M1 D1 from here, M1 D1 is 13 into 20 upon W1 is equal to M2 is 9 into D2 is what I want to find out upon work, which is half of W1. I can do this way also. So W1 will get cancelled. 2 will go above. So it will become 2. Okay, 2 will make this as 10. So D2 will be 130 by 9. So that's also fine. So either you use the formula or directly when the work is half. Earlier the work was 260 man days. Obviously now the work is half. So it will be 130 man days. Okay, so the answer is 14 4 by 9 days. Okay, if for a simpler version you can have only men and women. To make it more complicated, I have taken men, women as well as children. But this is how you will basically compare, reduce your work to man days, and then go ahead, proceed and get the answer. Okay, so I hope we are good here. There's one more variation of this where so this is where individual efficiency is known to me. So though efficiency I'm using the term, but basically what we had discussed earlier was this is I know individual efficiency. I know the capacity of men, women and children, and they're comparable. There's one more variety where individual efficiencies are not known to me, which is this one. If you see here, there is no data given like men is equal to so many women or is equal to so many children. I don't have that data. And this hence becomes slightly more complicated. And this has a very different approach, and understand this very carefully. 5 men, 6 women and 4 children can complete a piece of work in 10 days. Then you have 6 women, 6 children can complete work in 20 days. 2 men, 6 women can complete in 18 days. There's no comparison. Okay, so that individual efficiency, or how much is one man equal to in terms of women and in terms of children, I'll have to find that out. Okay, and understand how do we do that. 5 men plus 6 women plus 4 children finish some work in 10 days. Okay, they take 10 days. Now, if I want to finish this work in one day, what will I have to do? They finished this work in 10 days. Instead of 10 days, I want to finish the work in one day. I should make my team 10 times bigger. Right? So whatever is my team, if I make my team 10 times, then number of days required will become 1 by 10. So 10 into 1 by 10, that means one day. That we discuss in the concepts, right? So if my team becomes 10 times, my days required will become 1/10. So let's increase the whole team 10 times. So I have 50 men plus 60 women plus 40 children. They can finish the work in one day. Okay, let's look at the second case. So this is my equation 1. Second case, I have 6 women plus 6 children finishing the same work in 20 days. Same logic here. They're finishing 20 days. I want them to finish in one day. I should make my team 20 times. So 20 into 6, 120 women plus 120 children will finish the work in one day. This is my second equation. And then I have 2 men and 6 women finish in 18 days. 2 men plus 6 women finish it in 18 days. So I should make my team 18 times. So 18 into 2, 36 men plus 18 into 6, 108 women. They finish the work in one day. This is my third equation. Okay, now one very important part. All these teams, are they same? Because all these teams are finishing the same work in one day. One day, one day, one day. Okay, so the team is same. Okay, because man days, your day is one. So obviously your manpower is same. Okay, so all this manpower is equal to this manpower, which is equal to this manpower. I can say that. Okay, because they all are finishing the work in one day. Okay, so let's look at them. Let's solve them to get our desired ratio. Let's equate equation 1 and 2. 50 men plus 60 women plus 40 children is equal to 120 women plus 120 children. What does it give me? 50 men is equal to 120 women In fact, one thing we'll have to do, we ideally should look at, okay, let's solve from here. 120 women minus 60 women is equal to 60 women plus 80 children. Right? Okay. Then if I look at the third one, I have 120 women, 120 children in the second equation, and 36 men and 108 women in the third one. Okay, so which equation should I take next? Okay, so this is what I got by combining 1 and 2. Okay, similarly, let's combine 2 and 3. And then what do I get? 120 women plus 120 children is equal to 36 men plus 108 women. Okay, so 36 men, let's keep men on the left hand side, is equal to 120 minus 108, 12 women plus 120 children. And if I simplify this, I can cancel by 12. 3 men is equal to 1 woman plus 10 children. Or I cancel by 12, so 10 children. Right? So this can be my second equation. 3 men is equal to 1 woman plus 10 children. Okay. In the previous one also, what I got by combining 1 and 2, they all are multiples of 10. So in fact, let's remove that 10 to simplify it a bit. So 50, let's make it 5, 6 and 8. Okay, so I have these two equations. Now something I want to cancel here. Okay, let's say I want to cancel children so that I get a relation between men and women. So let's multiply the first one by 5 and the second one by 4. So then children will be 40, 40. So I'll get 25 men is equal to 30 women plus 40 children. And second one, 12 men is equal to 4 women plus 40 children. Subtracting the second one, I'll get 13 men is equal to 26 women. 13 men equal to 26 women, or 1 man is equal to 2 women. That is what I wanted. So I have 1 man is equal to 2 women. Let me put that anywhere here. 3 men. So I'm using this one. 3 men is equal to 1 woman. 1 woman basically means half man, right? So 0.5 men plus 10 children. 3 minus 0.5, that means 2.5 men is equal to 10 children, or 1 man is equal to 4 children. So 1 man is equal to 2 women is equal to 4 children is the ratio that I got, which was given to me in the previous question. So this much extra work is required here. And after we have this, then we proceed in the same manner to do the remaining part of the question. Okay. Okay, so let me erase everything else and just keep 1 man is equal to 2 women is equal to 4 children. So we have found out so far 1 man is equal to 2 women is equal to 4 children. This is okay. Now the same steps. So if I look at, in fact, I can look at any one. So 2 men, 6 women can complete the work in 18 days. So 2 men plus 6 women complete the work in 18 days. Okay, so 2 men is 2 men, 6 women is 3 men, total is 5 men, 5 men take 18 days, so my work is equal to 90 man days. Okay, and here also they have to finish the same work, so work is same, 90 man days, and I have 1 man, 2 women and 4 children. So 1 man is 1 man, 2 women is 1 man, 4 children also is 1 man, so net I have 3 men. So 3 men into days is equal to 90 man days. So obviously D is equal to 30. They are going to take 30 days. Hence my answer is 30. Okay, so this is the second variety where the individual efficiency is unknown, and you saw how we solve that. Okay, so basically equate the whole team to work done in 1 day. Okay, and so if first case they were doing the work in 10 days, I increase my team size to 10x. So obviously if the team becomes 10 times, days required will become 1/10. So 50 men, 60 women, 40 children can finish in 1 day. Similarly, the second time I increase my team to 20x, third time I increase the team to 18x. They all finish the work in 1 day. And since they are finishing the work in 1 day, same work in same time, my manpower is same. And then we equated, we got the ratio. This is the ratio that we got. And then you solve it the way we solved the previous question, right? So that's how this question has to be done. Okay. So this brings us to the end of the second class. So very important concept of man days or man hours is what we have focused here. And we did some more questions on the earlier versions. We did some advanced questions. Okay. So practice all that we have learned so far. Do a lot of questions. First solve multiple times the questions that we have solved, then solve some more questions from your practice material. And then in the next class, we are going to take on the concept of efficiency and wages, which I've avoided so far, but let's take that up and let's understand that concept also. Thank you so much. Take care. Bye-bye.